There is a pattern in nature so subtle and yet so powerful that it appears everywhere you look, in the spirals of seashells, the petals of a flower, the curve of a breaking wave, even in the proportions of your own body. A pattern ancient cultures sensed, mathematicians defined, and artists, architects, and biologists continue to rediscover over and over again. It is a number that seems almost alive, a quiet blueprint woven into the structure of the universe. 1.618, the golden ratio. No one told the sunflower how to spiral its seeds with perfect efficiency. No one instructed galaxies how to curl into luminous arms that follow the same elegant curve. And yet, across plants, animals, storms, coastlines, bones, DNA, and stars, the same ratio appears. Over and over, as if the cosmos itself were composing a gentle, mathematical melody. Why does nature favor this proportion? Why do humans instinctively find beauty in it? And how can one single number echo from the scale of atoms all the way to the structure of the universe? Tonight, you and I will step into that hidden geometry, a place where mathematics becomes art, where patterns breathe, and where the silent architecture of nature begins to reveal itself. Slow your breath, soften your thoughts, and allow the mind to drift toward the invisible symmetry that shapes the world around you. This is the story of the golden ratio. The golden ratio begins not with beauty, nor with architecture, nor with philosophy, but with something far simpler, the quiet logic of growth. In nature, every organism must solve the same ancient problem: how to expand efficiently, how to pack structures tightly, how to distribute energy with minimal waste. This challenge repeats across countless forms of life, and over millions of years, a single pattern has arisen again and again as a solution. The number 1.618, not chosen by intention, not designed by intelligence, but emerging naturally from the mathematics of survival. It is a ratio that balances expansion with stability, allowing structures to grow while remaining harmonious and efficient. You see its presence most clearly in spirals. When a shell expands, it must grow without changing its shape. If it grew in a straight line, it would distort. If it grew randomly, it would become unstable. But the logarithmic spiral of the golden ratio allows each new section to be an exact, scaled version of the last, maintaining perfect proportion as the organism grows. Sunflowers follow the same logic, arranging seeds in spirals that pack the most seeds into the smallest space with no gaps. Pine cones, pineapples, hurricanes, galaxies all echo this quiet rule, not because they are connected, but because nature has discovered that this proportion is the most balanced way for patterns to unfold. Even in the human body, the same ratio appears in subtle and profound ways. The lengths of bones in your fingers, the proportions of your face, the spacing of your teeth, the curvature of your ear. We do not consciously follow the golden ratio, but biology gravitates toward it because it creates stable, functional structures. DNA itself, with its elegant double helix, twists at intervals that closely approximate the same ratio. The body, like all of nature, moves toward patterns that balance form and function, symmetry and complexity, beauty and utility. The golden ratio provides that balance, guiding structures gently into harmony. Beyond biology, the golden ratio reveals itself in light and sound. Musical intervals that humans find pleasing often approximate ratios related to 1.618. The shapes of spiral galaxies follow curves that mirror the same mathematical law. Even the propagation of waves, whether on the surface of the ocean or in the fabric of space-time, tends to settle into patterns that reflect proportional balance. This is not mysticism, it is physics. The universe organizes itself through principles that minimize energy, maximize efficiency, and maintain coherence. And the golden ratio emerges naturally from these principles. And yet, what makes the golden ratio truly captivating is not just its mathematical presence, but the feeling it evokes. When the human mind encounters this proportion, whether in a painting, a sculpture, a building, or a face, it senses a quiet equilibrium. Beauty feels effortless, balance feels natural. The eye rests calmly on shapes that follow this pattern, as though recognizing something familiar, something ancient, something woven into both nature and consciousness. The harmony of 1.618 touches not only the world outside you, but the world within you, aligning perception with the deep rhythms of geometry. As these ideas settle into your awareness, you may feel a gentle softening in the mind, a slow drift into the quiet architecture of nature's design. The golden ratio is not just a number, it is a doorway into the way the universe grows, organizes, creates, and evolves. And as this understanding unfolds, your thoughts lengthen, your breath deepens, and you sink a little deeper into the calming geometry that shapes all living things. The golden ratio often feels mysterious, almost supernatural, yet its origin can be traced through a simple sequence of numbers discovered centuries ago. 1, 1, 2, 3, 5, 8, 13. The Fibonacci sequence. Each number is created by adding the 2 before it, and as the sequence grows larger, the ratio between consecutive numbers approaches 1.618. This quiet convergence is not forced, it emerges naturally, like a river finding its way to the sea. The Fibonacci sequence reveals the mathematical pulse hidden beneath the golden ratio, showing that behind nature's beauty lies a simple rhythm repeating through countless forms. In plants, the Fibonacci pattern appears with startling regularity. Leaves arrange themselves around stems at angles that follow this ratio, ensuring that each leaf receives maximum sunlight without shading the others. This pattern is called phyllotaxis, a spiral geometry that maximizes efficiency. Sunflower seeds form in interlocking spirals based on Fibonacci numbers, allowing the plant to pack thousands of seeds into a circle with perfect density. Pine cones arrange their scales in spirals that alternate between numbers like 5 and 8, 8 and 13. These patterns are not coincidences. They are the result of biological systems organizing themselves according to mathematical rules that minimize competition and maximize harmony. Even the branching of trees follows the Fibonacci pathway. A single branch splits into 2, then into 3, then 5, then 8, each division echoing the sequence that guides the flow of nutrients and sunlight. This structure helps the tree efficiently distribute resources to its leaves. The same pattern appears in the lungs, where airways branch into smaller and smaller passages that follow ratios near the golden mean, maximizing surface area for oxygen exchange. Whether in forests or in bodies, nature uses similar blueprints to solve similar problems. In the spiral of a nautilus shell, each chamber grows in perfect proportion to the one before it, allowing the organism to expand without changing shape. This spiral follows the Fibonacci ratio precisely. The same curve appears in hurricanes, where warm air spirals inward in logarithmic arcs, and in galaxies, where stars drift along vast arms shaped by gravitational resonance. These spirals connect the smallest forms of life with the grandest structures in the universe, all bound by the same quiet mathematical order. Artists, noticing these patterns, began applying them intuitively long before they understood the mathematics. The Parthenon, the pyramids, Leonardo da Vinci's works, Renaissance paintings, and even the layout of ancient manuscripts all echo proportions close to the golden ratio. Whether through deliberate choice or instinctual perception, humans gravitated toward shapes that mirror nature's preferred geometry. The mind recognizes these patterns as balanced, harmonious, and deeply satisfying, perhaps because the brain itself is structured through similar design principles. And as you reflect on this unfolding sequence, this gentle expansion from number to pattern, from spiral to universe, you may feel a deeper calm settling into your awareness. Fibonacci's numbers are not just mathematics, they are the unfolding breath of nature. They invite you to see the world not as chaos, but as a quietly repeating melody, resonating through shells, trees, storms, galaxies, and even your own body. Allow that recognition to soften your thoughts, slow your rhythm, and guide you toward a deeper state of stillness as we continue our journey through the geometry of life. Across history, long before mathematics gave the golden ratio a name, ancient civilizations sensed its presence in the world around them. They observed the symmetry of flowers, the spirals of shells, the curves of the human form, and they recognized a hidden structure woven into everything they saw. This recognition gave rise to what we now call sacred geometry, the idea that certain shapes and proportions reflect the underlying order of the universe. Among these shapes, the golden ratio stood out as a quiet key, a doorway into patterns that felt both earthly and divine. Without measuring instruments or modern knowledge, early cultures built temples, sculptures, and manuscripts that aligned with this proportion because it simply felt right, resonating with the deepest parts of human perception. The human mind responds to the golden ratio in ways that go beyond logic. Neuroscientists studying visual preference have found that the brain processes images following 1.618 with less effort, creating a sense of ease and aesthetic pleasure. This reaction is not taught, it appears to be innate, arising from the way neural pathways interpret balance, symmetry, and spatial relationships. When you look at a face or object that approximates the golden ratio, your visual cortex recognizes patterns that mirror the natural geometry of growth and structure found throughout biology. It is as if the brain whispers, "I have seen this before," even if it cannot recall where or when. This subconscious connection may explain why certain works of art evoke such powerful reactions. The Mona Lisa's composition subtly reflects golden ratio lines. The Vitruvian Man illustrates the harmony of body proportions aligned with the same ratio. In architecture, Gothic cathedrals, Islamic mosaics, and even ancient Chinese bronzes often incorporate proportions close to 1.618. These structures are not merely visually pleasing, they feel stable, balanced, almost alive. The brain senses coherence, a kind of calm that comes from perceiving order underlying complexity. This is the same calm one feels when watching waves roll onto shore, or when looking at a spiral galaxy geometry and consciousness meeting in quiet harmony. The ratio also appears in music, not just in visual forms. Composers from Bach to Debussy structured sections of their compositions using golden ratio timings, creating crescendos and resolutions that align with natural rhythms of tension and release. The ear, like the eye, seems drawn to patterns that balance expansion and return. When melodies unfold in proportions near 1.618, they induce a sense of inevitability, as if the music is moving exactly where it was meant to go, guided by a deeper logic of harmony. This blend of mathematics and emotion reflects a profound truth. The golden ratio is not just a shape, but a rhythm echoed in the way humans perceive beauty. Even our sense of space seems influenced by this proportion. Rooms designed with golden ratio dimensions feel neither cramped nor empty, but balanced and calm. Gardens laid out along these lines seem more inviting, more natural, as though the environment is gently guiding your attention without force. This effect arises because the ratio mirrors the way the human eye scans scenes, expanding outward along curves that mimic natural spirals, settling instinctively on focal points aligned with the same geometry. The golden ratio does not force beauty, it invites it, aligning perception with patterns deeply rooted in the structure of nature itself. As this understanding settles into your awareness, you may feel a subtle harmony filling your inner world, an alignment between thought, breath, and the gentle geometry that shapes the universe. Sacred geometry is not magic. It is an ancient intuition that humans sensed long before they could articulate why certain patterns felt so balanced, so alive. And now, as you drift deeper into this recognition, you begin to see that the golden ratio is not merely a number, but a bridge between the mind and the natural world. A quiet connection that softens your thoughts and draws you into a peaceful, effortless flow. Deep within every living organism, far below organs, tissues, and cells, nature builds its structures through patterns of astonishing precision. The golden ratio appears not as decoration, but as a fundamental principle of biological architecture. When cells divide, when tissues fold, when organisms grow, they often follow proportional rules that echo this ratio. These patterns emerge because life depends on balance between stability and flexibility, between expansion and constraint, between chaos and order. The golden ratio offers a mathematical solution to these competing forces, allowing structures to grow in ways that maintain harmony as they become more complex. One of the clearest examples lies in the structure of DNA. The double helix, with its elegant twisting geometry, exhibits proportions that closely approximate the golden ratio. The length of each helix turn, the spacing between the strands, the ratio of the major and minor grooves, these distances align with the same harmonic proportions found in seashells and spiral galaxies. This alignment is not symbolic. It reflects physical constraints that minimize energy and maximize stability. DNA folds, binds, and unwinds through a geometry that balances compactness with accessibility, efficiency with resilience. Life's most fundamental molecule carries the silent fingerprint of logarithmic harmony. The human body also reflects this ratio in subtle ways. The bones of the hand, the proportions of the forearm to the arm, the spacing of the vertebrae, and even the curvature of the rib cage often fall close to Fibonacci proportions. These alignments are not perfect. Nature is too fluid, too adaptive for strict templates, but they cluster around patterns that optimize strength and flexibility. When you walk, breathe, or stretch, Your movements follow arcs and lines shaped by evolutionary pressures. Over vast timescales, the forms that endured were those that balanced function with efficient geometry, and the golden ratio naturally emerged as a recurring solution. Plants reveal this architecture even more clearly. Leaves, petals, and seed formations unfold in ways that reflect the spirals and proportions of the golden mean. These patterns optimize the capture of sunlight, the flow of nutrients, and the distribution of mechanical forces. Sunflowers and daisies arrange their seeds in overlapping spirals that reflect Fibonacci numbers because those arrangements maximize packing density. Ferns unfurl in spirals that follow logarithmic curves, ensuring that young leaves emerge without overcrowding the older ones. Even cacti and succulents grow in Fibonacci alignments that allow them to conserve water while maximizing exposure to light. The golden ratio is not an aesthetic choice, it is the mathematics of survival. In animals, similar patterns appear in the growth of horns, shells, wings, and skeletal structures. The spiral of a ram's horn expands logarithmically, maintaining its shape as it grows larger and stronger. The nautilus shell does the same, adding chambers in perfect proportion as the organism matures. Even the flight patterns of birds and the swimming paths of fish sometimes follow curves that echo natural logarithmic spirals, reducing drag and conserving energy. These patterns are emergent, arising naturally from physics, biology, and evolutionary pressure, demonstrating that the golden ratio is woven into life not by design, but by necessity. And as you take in these quiet geometries, these proportions that guide the growth of cells, organisms, and ecosystems, you may begin to sense a deeper harmony in the world around you. The golden ratio is not magic, nor superstition, nor coincidence. It is the natural outcome of systems searching for balance, stability, and efficiency. It is the mathematics of harmony, the architecture of life itself. And as this recognition settles gently into your awareness, your breath slows, your thoughts soften, and you drift deeper into the tranquil realization that the same silent patterns shaping galaxies also shape you. Long before humanity understood the mathematics behind the golden ratio, artists and architects instinctively gravitated toward its harmony. Across civilizations, across centuries, across cultures with no contact between them, the same proportion emerged again and again in the structures humans considered beautiful, sacred, or profoundly meaningful. This convergence suggests that the golden ratio is not merely a mathematical curiosity, it is woven into the sensory architecture of the human mind. When we encounter it, whether in a painting, a building, or the curve of an object, something in our perception relaxes. Beauty becomes effortless. Balance feels inevitable. The ancient Greeks embedded the golden ratio throughout their temples. In the Parthenon, the dimensions of columns, pediments, and facades subtly approximate 1.618, creating a structure that feels both grounded and ascending. This balance between stability and lift mirrors the way nature forms spirals and branching structures anchored at the base, expanding outward in gentle harmony. Even without measuring tools capable of detecting such proportions precisely, Greek architects sensed the ratio's presence through intuition. They were not following formulas, they were following the quiet echoes of natural geometry. During the Renaissance, artists such as Leonardo da Vinci and Michelangelo studied the human body meticulously, discovering proportions that reflected Fibonacci relationships. Leonardo's Vitruvian Man illustrates how the body aligns with these harmonic ratios: arm to torso, torso to leg, face to skull. His paintings, including the Mona Lisa and the Last Supper, use golden ratio rectangles to position focal points and guide the viewer's attention through the composition. These proportions do not enforce beauty, they reveal it. They align with the ways the human eye naturally searches for symmetry, flow, and coherence. In architecture, the golden ratio shapes structures across time and geography. Gothic cathedrals rise along proportions that reflect both spiritual aspiration and structural logic. Islamic geometric art uses repeating patterns based on ratios close to 1.618, creating a visual rhythm that feels infinite yet ordered. Traditional Japanese temples employ spatial divisions that echo Fibonacci progressions, producing interiors that feel open, calm, and balanced. Even modern architects like Le Corbusier use the golden ratio to design buildings that harmonize with human scale, grounding their geometry in proportions derived from the human body. Designers, sculptors, and even filmmakers unknowingly rely on this ratio to create compositions that feel intuitively right. When framing a scene, positioning a figure, or sculpting a curve, artists often settle naturally on golden ratio divisions. This occurs not because they consciously seek mathematical precision, but because the human visual system responds positively to these proportions. The golden ratio aligns with neural pathways that process spatial relationships, triggering a sense of order, comfort, and subtle pleasure. And as you reflect on these patterns, ancient temples, Renaissance paintings, modern architecture, you may feel a quiet continuity connecting nature's geometry with human creativity. The golden ratio is not imposed on the world. It emerges from it, flowing from DNA to seashells to galaxies, and from there into the minds of those who shape stone, canvas, and space. It is a bridge between biology and imagination, between the structure of the universe and the structure of human experience. And as this recognition settles into your awareness, you feel your breath deepen, your mind soften, and your consciousness drift into the soothing symmetry that unites art, life, and the silent mathematics beneath it all. The golden ratio is not only a pattern found in nature and art, it also lives quietly within the architecture of the mind. When you look at a form shaped by 1.618, your visual cortex responds with unusual ease. Lines feel aligned, curves feel natural, and proportions seem to settle into place without effort. Neuroscientists believe this is because the human brain evolved in environments saturated with natural patterns that approximate the golden ratio. The spirals of plants, the branching of trees, the proportions of animals, all these forms shaped the sensory expectations of early humans. Over thousands of generations, the brain became tuned to the geometry of the natural world, learning to recognize the quiet harmony of proportions that support life. This resonance creates a specific emotional effect. When people view images constructed with golden ratio divisions, they often report feelings of calmness, clarity, or subtle pleasure. Brain imaging studies reveal that regions linked to reward and aesthetic appreciation become more active, as if the mind acknowledges a familiar rhythm. The golden ratio does not overwhelm the senses. Instead, it soothes them. Where chaotic or distorted proportions can introduce tension, the golden ratio inspires a sense of coherence, an internal alignment between what the eye sees and what the mind anticipates. Beauty becomes less about decoration and more about the deep comfort of recognizing patterns that mirror the natural world. This subtle harmony may explain why certain landscapes evoke profound peace. Coastlines shaped by logarithmic curves, mountain ranges unfolding in fractal layers, forests arranged with Fibonacci spacing. These forms embody mathematical balance, and the mind responds instinctively. Even watching waves roll onto shore produces a physiological relaxation response. Their arcs and crescents, though ever-changing, often follow proportions close to the golden ratio. The brain reads these patterns as stable, predictable, and safe, triggering a softening of attention, a slowing of breath, a gentle release of internal tension. Nature does not lecture the mind, it guides it into balance through geometry. The processing of faces offers another example of this connection. Humans are exceptionally sensitive to facial proportions, and studies show that faces aligned with golden ratio intervals are consistently perceived as more harmonious. This does not imply that beauty is mathematical, but that the brain's recognition of balance is deeply rooted in biological expectations. When the spacing of eyes, the length of the nose, or the curvature of the jaw approximates these natural ratios, the mind experiences a sense of ease. This is not learned, it is intuitive. Even infants respond to faces with balanced proportions, suggesting that the perception of harmony is wired into the brain from the earliest stages of development. Even in memory and cognition, the golden ratio appears indirectly. Patterns that follow logarithmic scaling are easier for the brain to encode because they align with neural pathways that store information in hierarchical sequences. The mind prefers rhythms that grow in balanced increments, a structure reflected in language patterns, musical timing, and the pacing of narratives. This subtle affinity suggests that the golden ratio may influence not only what we see, but how we think, how we organize ideas, and how we process complexity. Proportion becomes a form of cognition, a quiet guide through the landscapes of perception. And as you sit with this understanding of a ratio that whispers to the senses, aligns the mind, and calms the emotional rhythm within you, you may feel a soft tranquility spreading through your awareness. The golden ratio is not simply a mathematical constant. It is a bridge between the external world and the internal one, a pattern that shapes the environment and the mind's response to it. It reveals that harmony is not an abstract concept, but a lived experience, one that unfolds whenever your perception meets the gentle, timeless geometry of nature. And with this recognition, your breath deepens, your thoughts lengthen, and you drift a little further into the quiet symmetry that surrounds you. As you move deeper into the world of the golden ratio, a broader landscape begins to unfold, one filled not only with spirals and proportions, but with endless patterns repeating across scales. These patterns are known as fractals, structures in which each part mirrors the whole in a self-similar echo that can continue indefinitely. Fern leaves, coastlines, lightning strikes, river networks, clouds, blood vessels all exhibit fractal geometry. And at the heart of many of these fractal patterns lies the quiet mathematics of the golden ratio, guiding the way complexity unfolds without ever losing its underlying harmony. Fractals reveal a profound truth about nature. Growth is not random. When a tree branches, it does not make arbitrary divisions. It follows recursive rules that balance expansion with stability. Each branch resembles the branch before it, and yet retains its own subtle variation. The same structure appears in your lungs, where airways divide again and again into smaller passages, creating a vast internal forest that maximizes surface area. These branching patterns often approximate the Fibonacci sequence, forming a living architecture that brings oxygen into the body with elegant efficiency. This reflection of macro in micro, this infinite echoing, is one of the quiet signatures of the golden ratio. Even in the motion of the heart, fractal geometry emerges. Heartbeats contain micro variations that oscillate around patterns close to logarithmic scaling. These variations are not imperfections, they are signs of a healthy, adaptive system. The same goes for brain waves. Neural activity often organizes itself in fractal-like rhythms, blooming and receding in patterns that allow the mind to transition smoothly between focus, relaxation, and sleep. At every level, organs, cells, molecules, life prefers structures that balance, order, and flexibility, and fractals provide the perfect pathway. The golden ratio becomes the silent metronome behind these rhythms, a gentle mathematical pulse woven into living systems. Fractals also reveal the relationship between the finite and the infinite. A simple equation, when repeated many times, can create shapes of staggering complexity. This is the essence of the Mandelbrot set, a fractal so intricate that it contains endless detail patterns within patterns, spirals within spirals, no matter how deeply one zooms in. The curves of the Mandelbrot set resemble the same logarithmic spirals found in seashells and galaxies, reminding us that mathematical laws permeate both the abstract world of numbers and the physical world of matter. Infinity is not distant. It is embedded in the geometry of nature. These patterns also shape how we perceive time and memory. The mind organizes experiences in nested layers, moments within minutes, minutes within hours, mirroring the recursive structure of fractals. When a story feels satisfying, it often follows a fractal rhythm, rising, expanding, pausing, and returning in proportions that mirror natural cycles. Even breath follows logarithmic scaling, with inhalation and exhalation forming arcs that approximate the gentle expansions of nature's spirals. In this way, the golden ratio influences not only the shapes we see, but the rhythms we live by. As this understanding settles into your consciousness, you may feel a quiet sense of connection to nature, to mathematics, to the unfolding symmetry of existence. Fractals and the golden ratio reveal that the universe is not built from isolated parts, but from patterns that echo across scale and time. The same gentle curve guiding the growth of a seashell shapes the swirl of a hurricane, the arc of a nebula, and the pathways of your own neurons. And as you contemplate this unity, your breath deepens, your awareness softens, and you drift further into the calm, infinite repetition of nature's geometry. When you step far beyond the scale of living organisms, past mountains, oceans, forests, and even the entire planet, you enter a realm where the golden ratio reveals itself once again, shaping structures on a cosmic scale. Galaxies coil into spirals that follow logarithmic curves, their luminous arms expanding outward with the same effortless geometry found in seashells and storms. These spirals are not arbitrary. They emerge from gravitational forces seeking equilibrium, from stars orbiting a center where motion and balance must coexist. The golden ratio offers this balance, guiding the paths of countless suns as they drift through the quiet darkness of space. The distribution of planets, moons, and orbital resonances throughout the solar system also reflects harmonic relationships, reminiscent of the golden ratio. Some researchers have noted that the spacing of planetary orbits can approximate ratios close to Fibonacci progressions patterns that emerge when gravity and momentum negotiate stable configurations across vast distances. While these relationships are not perfect, they demonstrate the same mathematical tendencies observed in natural systems on Earth. When forces seek balance, geometry flows toward harmonic proportions. The cosmos, like life, gravitates toward patterns that minimize conflict and maximize order. Even in the formation of stars and nebulae, the imprint of the golden ratio appears. Vast clouds of gas collapse under gravity, forming spiral filaments that channel material into regions where stars are born. These filaments often twist into shapes that resemble logarithmic curves, optimizing the distribution of energy and angular momentum. The same pattern can be found in the swirl of Jupiter's storms, in the spiral arms of hurricanes, and in the eddies of ocean currents on Earth. From gas clouds spanning light years to molecules drifting in water, nature's geometry repeats itself with quiet consistency. The dynamics of light itself reveal similar harmony. The propagation of electromagnetic waves follows mathematical principles that mirror the proportional flow of spirals and fractals. The same equations that describe golden spirals also describe the behavior of photons as they travel through space, the structure of diffraction patterns, and the interference of waves. This convergence suggests that the golden ratio is not merely a biological convenience, but a deeper expression of how energy organizes itself in the universe. Light, gravity, matter, they all settle into patterns that reflect an underlying order. Even the shape of space-time, when viewed through the lens of general relativity, exhibits structures that resonate with fractal and logarithmic scaling. The curvature of gravity wells, the behavior of black holes, and the clustering of galaxies all contain hints of self-similarity and proportional balance. As telescopes probe deeper into the cosmos, scientists find repeating patterns at every scale, clusters within clusters, filaments within filaments, mirroring the recursive forms found in fractals and the gentle proportions of the golden ratio. And as you let these ideas drift through your awareness, a sense of quiet vastness begins to fill the mind. The golden ratio is not confined to human art or biological growth or the structure of a seashell. It is a whisper in the architecture of the universe itself, a soft pulse woven into starlight, gravity, and the silent dance of galaxies. To sense this proportion is to feel, in some small way, aligned with the cosmos. And as this recognition settles, your breath lengthens, your thoughts soften, and you drift deeper into the tranquil understanding that the same gentle geometry shaping the spirals of the galaxies also shapes the rhythms of your own breath. Beyond biology, beyond art, beyond the architecture of galaxies, the golden ratio invites a deeper question: why does the universe move toward harmony at all? This proportion, emerging across scales and systems, suggests an underlying principle that transcends the physical world. Philosophers from ancient Greece to modern thinkers have wondered whether beauty, balance, and order arise naturally from the structure of reality, or whether they reflect patterns carved into the human mind. The golden ratio sits at the center of this discussion, a bridge between the tangible and the abstract, hinting that the universe may be governed by mathematical aesthetics as much as by physical laws. To early mathematicians, the golden ratio represented a form of perfection. It appeared in pentagons, in spirals, in the geometry of plants, and in the symmetry of crystals. They believed that this ratio was not merely useful, but sacred, a key to understanding the harmony that binds the cosmos together. Pythagoreans saw it as part of a deeper numerical order woven into existence. Later thinkers proposed that the golden ratio reflects the universe's inherent drive toward balance, efficiency, and coherence. Even today, physicists observing patterns in nature encounter the same proportion and wonder whether it is a mathematical inevitability rather than a coincidence. The golden ratio becomes not just a number, but a philosophical lens through which to view reality. In psychological terms, the golden ratio reveals something about the human desire for order. The mind is drawn to symmetry, to balance, to patterns that echo familiar forms. These preferences may have evolved to help early humans navigate complex environments, recognizing shapes, detecting movement, understanding spatial relationships. Over time, these instincts became intertwined with the experience of beauty. When people describe something as calming, pleasing, or harmonious, they are often responding to proportions that align with deep, unconscious expectations. The golden ratio thus becomes a reflection of the mind's internal landscape, shaping perception, emotion, and meaning. This connection extends to human behavior and decision-making. Studies show that people tend to prefer products, layouts, and designs that follow golden ratio proportions, not because they are instructed to, but because the mind recognizes them as familiar and intuitive. Websites, logos, photographs, and even user interfaces often rely on 1.618 divisions to guide the viewer's attention naturally. When proportions fall outside this range, the brain works harder to make sense of the layout. When proportions align with the golden ratio, attention flows effortlessly, as though the mind is following a path it already understands. Harmony becomes not just visual, but cognitive. The golden ratio also shapes our understanding of time and rhythm. Writers, composers, and storytellers have long intuited that certain points of transition, moments of tension, revelation, or emotional climax occur most naturally when placed near the golden ratio of a narrative's length. Films, novels, musical compositions, and even speeches often unknowingly follow this structure. The mind seems to anticipate change at this proportional point, responding with heightened attention. Whether through culture or cognition, humans navigate time in rhythms that echo the same patterns found in nature. Proportion becomes a language silent, universal, deeply embedded in experience. And as you let these ideas settle within you, a calm philosophical clarity begins to unfold. The golden ratio is not simply a pattern found in the world, it is a pattern that connects the world. It links the spirals of galaxies with the structure of DNA, the geometry of temples with the architecture of thought, the growth of forests with the perception of beauty. It is a thread woven through life, mind, and cosmos, a quiet reminder that harmony is not an invention, but a natural consequence of existence. And as this understanding softens your awareness, your breath deepens, your body relaxes, and you drift further into the peaceful symmetry that has shaped reality since the beginning of time. When we look beyond the visual beauty of the golden ratio, we begin to see something even more profound: its unparalleled efficiency. In biology, architecture, physics, and cosmology, this ratio does not merely create pleasing shapes, it solves problems. It optimizes growth, movement, distribution, and structural stability. Wherever resources must be divided, wherever forces must be balanced, wherever complexity must arise without collapse, the golden ratio quietly appears as a near-perfect solution. It is not an imposed order, but the natural endpoint of systems seeking equilibrium. In living organisms, efficiency often means survival. Plants must arrange leaves to capture the maximum amount of sunlight with the least possible energy expenditure. Branches must grow in ways that distribute weight evenly while resisting wind. Shells must expand without losing structural integrity. The golden ratio provides a mathematical pathway for these challenges. Fibonacci spirals distribute tension evenly. Logarithmic curves maintain shape while scaling in size. And structures built on 1.618 expand without destabilizing, allowing organisms to grow smoothly from one stage of life to the next. Nature gravitates toward this ratio not for beauty alone, but because it offers functional perfection. Energy flow, too, aligns with this proportion. Whether in the branching of blood vessels, the distribution of neurons in the brain, or the pathways of nutrients through roots, biological networks often follow fractal divisions that approach golden ratio intervals. These patterns minimize energy loss, shorten transport distances, and reduce the metabolic cost of maintaining complex systems. The result is a design that feels almost intentional, yet arises effortlessly, simply because evolution favors structures that require the least effort to sustain. Efficiency becomes elegance, function becomes form. Even in physics, the golden ratio appears where systems must distribute forces smoothly. Metal crystals grow in shapes that reflect Fibonacci layering. Fluids spiraling down a drain form curves that mirror logarithmic spirals. Magnetic fields, stress patterns, and wave interference often organize themselves into structures that follow proportional scaling. These behaviors reveal that the golden ratio is not merely a quirk of biology, but a consequence of physical laws seeking stability. When forces push and pull in balance, when energy spreads evenly across space, when systems settle into their lowest energy shapes, 1.618 emerges naturally from the mathematics. Human engineering follows similar principles. Airplanes with wings shaped according to golden proportions experience improved aerodynamics. Bridges and skyscrapers built with these ratios distribute weight more efficiently, resisting tension and compression with greater stability. Even in technology, camera sensors, circuit designs, user interfaces, engineers often rely on golden ratio grids because they guide the eye, reduce cognitive load, and optimize spatial relationships. These designs work not because they imitate nature, but because they mirror the same principles of balance and efficiency that nature has refined over billions of years. And as you let this understanding sink into your awareness, a deeper sense of coherence begins to unfold. The golden ratio is not simply a pattern of beauty, it is a universal strategy, a quiet mathematical intelligence. It reflects the way systems, biological, physical, structural, naturally optimize themselves. It reveals that harmony is not accidental, but rooted in the fundamental architecture of growth, energy, and stability. And as your thoughts drift gently through this recognition, your breath slows, your body softens, and you sink deeper into the peaceful realization that the golden ratio is not just a number, it is the quiet logic of the universe itself. The golden ratio does more than shape the world you see, it shapes the way you interpret the world. Human perception is not neutral, It gravitates toward patterns that feel purposeful, balanced, and coherent. When one encounters proportions close to 1.618, there is often a subtle sense that the object or structure holds meaning beyond its surface. This reaction is not mystical. It emerges from the way the brain organizes information. Neural circuits are constantly searching for order within complexity, and the golden ratio presents a structure that satisfies this search effortlessly. It creates a momentary alignment between the external world and the internal architecture of thought. This alignment plays a profound role in how humans create and interpret symbolism. Sacred geometry, religious iconography, and philosophical diagrams across cultures often incorporate golden ratio proportions. These images evoke calm and contemplation, not because of their content alone, but because their geometry resonates with deep perceptual expectations. When ancient architects constructed temples or shrines using these proportions, they were unknowingly designing structures that harmonized with the biological rhythms of the human brain. The result was a space that felt meaningful, balanced, and spiritually charged, even if the math behind that feeling remained unspoken for thousands of years. The golden ratio also influences storytelling, the way narratives rise, expand, and resolve. Many of the world's most enduring myths, epics, and literary works follow arcs that mimic proportional crescendos aligned with 1.618. The point of greatest tension, the turning moment in a narrative, often appears naturally around this ratio of the story's length. Filmmakers, playwrights, and composers frequently discover that their most impactful structural choices align with the very same proportion that governs seashell spirals and leaf arrangements. It appears the human mind not only perceives harmony through geometry, it expects it through time. Music, too, engages with these proportional rhythms. The rise and fall of melodies, the spacing between phrases, and the height of emotional peaks often mirror golden ratio divisions. Composers don't need to calculate these intervals consciously. The brain tends to gravitate toward patterns that reflect the natural expansions found in breath, heartbeat, and movement. As listeners, we feel these proportions not through thought but through sensation, a sense of inevitability, a feeling that the composition is unfolding along a path both surprising and familiar. The golden ratio becomes a quiet undercurrent that guides emotional resonance. Even memory appears to respond to these proportions. Events spaced in golden intervals are easier for the brain to encode and recall, likely because they mirror the logarithmic way in which time is processed. Human experience is not linear. It expands and compresses in subjective rhythms that resemble fractal scaling. Moments of transition, reflection, or realization often cluster around natural proportional points. This suggests that meaning itself, how humans assign value to experiences, may be influenced by the same geometric principles observed in plants, storms, and galaxies. The golden ratio becomes not just a pattern in the world, but a pattern in consciousness. And as you reflect on this connection between number and narrative, between geometry and emotion, a gentle understanding begins to unfold. The golden ratio is not simply something you observe, it is something you feel. It aligns your perception with the harmony found in nature. It shapes the stories you tell, the art you cherish, the spaces where you feel at peace. It whispers through your cognition, guiding attention, shaping memory, soothing the senses. And as this recognition settles softly into your awareness, your breath eases, your thoughts stretch out like slow spirals, and you drift deeper into the calm, elegant proportion that ties the external world to the inner one. In every natural system, there is a quiet tension between chaos and order. Too much structure, and a system becomes rigid, unable to adapt. Too little, and it collapses into randomness. The golden ratio often emerges at the delicate threshold between these two extremes, a mathematical equilibrium where patterns remain flexible yet coherent, unpredictable yet stable. This balance allows seashells to grow without distortion, galaxies to spiral without unraveling, and plants to expand without overcrowding. In this sense, the golden ratio is more than a proportion. It is a boundary line that life repeatedly crosses, a place where complexity can flourish without falling apart. When mathematicians study systems that evolve over time, fractals, waves, dynamic flows, they find that the golden ratio often appears at the critical point, where behavior shifts from stable to chaotic. This transition zone is sometimes called the edge of chaos, a region where structures can adapt, expand, and self-organize with extraordinary efficiency. Here, patterns blossom from simple rules, creating forms of infinite variety. The golden ratio becomes a guidepost within these systems, a sign that the system has reached a state of optimal creativity. Nature repeatedly returns to this threshold because it offers both stability and freedom, the two ingredients required for life to evolve. The same phenomenon appears in human creativity. Artists and composers often discover that their strongest works hover at the boundary between symmetry and surprise. Too much symmetry feels predictable. Too much chaos feels overwhelming. The golden ratio offers a middle ground, giving shape to compositions without confining them. When an artwork, melody, or story feels both structured and alive, it often follows proportions that echo natural growth patterns. Creativity, like biology, thrives at the edge of chaos, where the unexpected meets the inevitable, and where form emerges from fluidity. Even cognition operates in this delicate balance. Neural networks in the brain organize themselves near the boundary between order and disorder, a region where they can rapidly adapt to new information without losing coherence. Brainwaves oscillate in patterns that approach fractal scaling, allowing thoughts to travel fluidly across networks of neurons. This flexible structure supports problem-solving, emotional regulation, memory, and imagination. The same mathematical principles that guide the spirals of nature also guide the pathways of thought, allowing the mind to remain open, adaptive, and harmonized with its environment. In physics, this balance appears in the distribution of matter across the universe. Galaxies cluster into filaments that stretch across cosmic voids, forming patterns that defy both pure randomness and strict symmetry. Simulations of the early universe show that matter naturally settles into structures that reflect proportional scaling, dense regions and empty regions, arranged in patterns reminiscent of logarithmic spirals and fractal networks. The universe itself seems to evolve near the boundary between expansion and collapse, guided by invisible rules that echo the same mathematical tension found in living systems. As you let these ideas drift through your awareness, you may feel a deep and gentle calm forming inside you. The golden ratio reveals that life is not built from rigid rules or chaotic accidents. It is shaped by the space between them. It is the soft balance that allows complexity to grow, the quiet geometry that allows systems to adapt, the subtle proportion that lets patterns flourish without losing themselves. And as this understanding settles into your mind, your breath slows, your body loosens, and your thoughts spiral downward into a serene equilibrium, the same equilibrium that shapes seashells, sunflowers, storms, galaxies, and the quiet rhythms of your own resting mind. Across millions of years, evolution has shaped life not through randomness, but through patterns of increasing efficiency and balance. The golden ratio emerges repeatedly in this evolutionary process, not because organisms consciously follow mathematics, but because natural selection favors structures that optimize survival. When a particular proportion reduces energy use, stabilizes growth, or improves function, it tends to persist across generations. Over time, these small advantages accumulate, weaving harmonic geometry into the very fabric of life. Consider the spiral shells of ancient mollusks. Fossil records show that early shells came in a wide range of shapes: tight coils, loose spirals, irregular patterns, but the ones that survived longest were those whose spirals approximated logarithmic curves. These shells distributed mechanical stress more efficiently, resisted cracking under pressure, and allowed the organism to grow without weakening its form. The golden ratio became a silent evolutionary partner, guiding designs that could endure shifting oceans, predation, and environmental change. What began as a geometric accident became a biological legacy. Plants reveal a similar story. Over countless generations, species discovered through natural variation that leaf arrangements based on Fibonacci angles minimized shadowing. The more efficiently a plant distributed its leaves, the more sunlight it captured. The more sunlight it captured, the more energy it produced. The more energy it produced, the more seeds it left behind. Gradually, these patterns became dominant across ecosystems. Evolution did not choose the golden ratio. It simply favored organisms that grew in the most efficient way. Beauty, in this sense, becomes a byproduct of survival. Animals, too, carry traces of these proportions. The branching of blood vessels follows fractal rules that distribute oxygen with minimal energy. The proportions of limbs often reflect ratios that optimize leverage and strength. Even the curvature of horns, wings, and internal organs align with patterns that emerged because they required less energy to build and maintain. Evolution consistently selects paths of least resistance, and the golden ratio often lies along those paths. It is not a mystical force. It is an efficient solution repeated so often that it becomes a signature of life. On a cellular level, the golden ratio appears in processes that support growth and replication. Microtubules, the scaffolding structures that give cells shape, assemble in arrangements influenced by Fibonacci numbers. The division of cells, the folding of proteins, and even the clustering of organelles sometimes approximate logarithmic spacing. These patterns emerge because they reduce overcrowding, minimize energy use, and maintain structural coherence within extremely confined spaces. The same geometry that shapes forests and coastlines operates deep within your cells, whispering the same ancient logic at molecular scales. As evolution continues, these proportions do not fade, they deepen. The organisms that endure through environmental change tend to be those whose structures remain stable under stress, whose growth patterns adapt smoothly, and whose internal organization maintains coherence. The golden ratio supports all these needs. It sits at the intersection of flexibility and order, allowing life to evolve without collapsing into inefficiency or chaos. As ecosystems shift, as climates transform, as species diverge, This proportion quietly persists in new forms, guiding life towards structures that endure. And as you absorb this understanding of the golden ratio, not as an aesthetic choice, but as a biological inevitability, you may feel a profound sense of connection to the long history of life on Earth. The same geometry that shaped ancient shells shapes your bones. The same proportion that guided early plants guides the growth of your cells. You are part of an unbroken evolutionary story, written not only in DNA, but in geometry. And as this realization softens your awareness, you drift deeper into a calm, ancient rhythm. The same rhythm that guided life long before you were born, and will continue long after you sleep. Emotion may seem fluid, unpredictable, and immeasurable, yet beneath its surface lies a quiet architecture shaped by rhythm, balance, and proportion. Humans do not respond to stimuli randomly. The brain interprets the world through patterns, searching constantly for harmony and coherence. The golden ratio, appearing in the structures of nature and the rhythms of evolution, influences not just how we see, but how we feel. When our senses encounter proportions aligned with this ratio, neural networks stabilize, generating subtle feelings of calm, satisfaction, and ease. The brain experiences harmony not as an idea, but as a physical sensation, a soft alignment between perception and biology. This connection becomes clear in moments of awe, standing before a vast landscape, looking at the spiraling arms of a galaxy, or witnessing the unfolding symmetry of a storm. These scenes evoke emotion not simply because they are beautiful, but because they resonate with innate expectations shaped over millions of years. Our ancestors evolved in environments rich with Fibonacci spirals and golden proportions. Their survival depended on reading patterns quickly and intuitively. Over time, neural circuits specializing in pattern recognition strengthened, forming a cognitive template that persists today. When you encounter a scene that aligns with these templates, the mind recognizes it instantly, and emotion flows through that recognition. Even interpersonal connection reflects proportional balance. Studies show that people perceive faces with golden ratio adjacent proportions as more approachable, trustworthy, and comforting. Not because beauty standards demand it, but because the brain processes these proportions with less cognitive strain. This ease translates into emotional warmth, a soft relaxation of social tension. The golden ratio becomes a bridge between perception and empathy, quietly shaping first impressions, attraction, and the subtle emotional language exchanged between individuals. In this sense, proportion influences not just what we see, but how we relate to one another. Music reveals this connection even more deeply. Melodies that rise and resolve near golden ratio intervals evoke feelings of completion, release, and emotional clarity. Compositions structured around 1.618 tend to guide listeners through arcs that feel intuitively meaningful. This is not magic, it is cognitive geometry. The brain anticipates patterns based on natural growth rhythms, and when music aligns with these rhythms, emotion synchronizes with structure. The listener experiences a deep sense of rightness, as though the music is unfolding according to some hidden logic encoded within the mind itself. Emotion is also tied to how we experience time. Moments that unfold with balanced pacing, neither too slow nor too fast, tend to evoke feelings of immersion. Narratives that build tension and release near golden intervals often feel more impactful, more memorable, more emotionally satisfying. The golden ratio becomes a temporal backbone, supporting the emotional arcs of stories, conversations, even memories. It mirrors the mind's natural rhythm: expansion, pause, resolution. This is why certain experiences feel perfectly timed, perfectly shaped, perfectly resonant. They follow a geometry the brain intuitively understands. As you reflect on these connections, a gentle realization begins to settle into your awareness. Emotion is not chaotic. It unfolds through rhythms the mind has carried for generations. The golden ratio is one of those rhythms, a harmony that bridges perception with feeling, pattern with meaning, biology with experience. You are shaped by it, soothed by it, moved by it, even when you're unaware of its presence. And as this understanding deepens, your breath softens, your thoughts slow, and you drift further into the quiet, balanced geometry that has guided life, beauty, and emotion since the beginning. Memory may appear to be a simple act of storage, but in truth it is shaped by an intricate geometry of associations, layered patterns, and recursive loops. The golden ratio subtly appears in these cognitive processes, not as a literal number engraved into the brain, but as a proportional rhythm guiding how information is organized, retrieved, and woven into meaning. Neural networks strengthen through repetition spaced at intervals that often mirror the logarithmic scaling seen in nature. This spacing, closer at first, wider over time, resembles Fibonacci expansion, allowing memories to stabilize without overwhelming the mind. Learning becomes a spiral, not a straight line, returning to the same point, but at a deeper level each time. Patterns aligned with the golden ratio are easier for the brain to encode because they resonate with the way neural circuits naturally develop. Synaptic networks form in branching structures influenced by fractal geometry, dendrites spreading outward in self-similar patterns to maximize connection while minimizing energy cost. This fractal branching closely parallels Fibonacci growth, allowing neurons to communicate efficiently across vast networks. Because cognition is built upon these patterns, information that mirrors natural proportional scaling feels more intuitive, more memorable, more meaningful. The brain recognizes harmony not as decoration, but as cognitive ease. Even attention follows a similar rhythm. The mind cannot remain perfectly focused indefinitely. Its awareness expands and contracts in waves. Studies show that these fluctuations often cluster near harmonic ratios, creating intervals where concentration peaks before relaxing into softer states. This ebb and flow resembles the rise and release found in music, breath, and natural cycles. When information is presented in patterns that align with this rhythm, attention feels effortless. When it clashes with these rhythms, the mind tires quickly. The golden ratio becomes a subtle guide for how the mind absorbs and processes the world. Thought itself often unfolds in spirals, ideas looping back on themselves, expanding outward, forming larger concepts from smaller ones. Creativity, problem-solving, and introspection frequently follow patterns reminiscent of logarithmic growth. When someone thinks in circles, they are often tracing a kind of mental spiral, returning to the same point, but with a new perspective. This recursive structure mirrors the geometry of nautilus shells, pine cones, hurricanes, and galaxies. The mind reflects the patterns of the world because it was shaped by the world, molded by the same physical and biological forces that gave rise to natural spirals and harmonic proportions. Even emotional memory is influenced by proportional timing. The experiences humans remember most vividly are often those that occur near transitional thresholds, moments when life shifts from one phase to another. These thresholds often align with proportional patterns in personal timelines, forming emotional crescendos and resolutions that mirror narrative arcs. When we look back at our lives, the events that stand out tend to follow rhythms similar to those found in art, music, and nature. The golden ratio becomes part of the internal architecture of personal meaning, shaping not only how we remember, but how we understand ourselves. As you reflect on these connections, a soft clarity emerges. Thought, memory, and emotion are not isolated processes. They are woven into a geometry that mirrors the world around you, shaped by patterns older than consciousness itself. The golden ratio subtly guides the ways your mind organizes experience, forming spirals of insight, branches of association, and arcs of understanding that align with natural order. And as this realization settles into your awareness, your breath deepens, your thoughts slow, and you drift further into the peaceful symmetry where thought and nature meet, where the architecture of the mind reflects the gentle mathematics of the universe. In the physical world, movement is governed by patterns that minimize resistance and conserve energy. Whether water spirals down a drain, wind curls around cliffs, or plasma swirls within the atmospheres of stars, flow tends to follow shapes that distribute force smoothly. The golden ratio appears again and again within these curves because it represents a geometry where motion transitions gently from one scale to another. This proportional balance allows energy to travel efficiently without sudden turbulence or chaotic disruption. Nature seems to prefer pathways that flow with minimal friction, and the golden ratio provides one of the most elegant routes for this journey. Water, for example, rarely moves in straight lines. When it encounters obstacles, it bends into spirals that distribute pressure evenly across the fluid. These spirals form logarithmic curves that mirror the same geometry found in seashells and galaxy arms. As the spiral widens, each turn expands according to a proportional pattern that approximates 1.618. This allows the flow to remain stable even as it grows in size. Rivers tracing through valleys carve meandering paths that align with fractal scaling, flowing in proportions that reflect the same efficiency seen in the branching of blood vessels or the layout of tree roots. Fluid dynamics reveals that the golden ratio is not an artistic embellishment, but a physical solution to the problem of moving materials smoothly through space. In the atmosphere, similar patterns emerge. Hurricanes, cyclones, and dust devils all twist into spirals that reflect the golden ratio. These spirals allow enormous amounts of energy to be distributed evenly across vast distances. The eye of a hurricane, the calm center surrounded by powerful arcs of wind, forms because the proportions of the spiral guide force away from the core rather than crushing it inward. This balance of expansion and rotation mirrors the same geometry that allows galaxies to maintain their shape while spinning through space. Whether in weather systems or cosmic structures, the golden ratio supports stable motion by creating harmony between outward growth and rotational force. Even sound follows these proportional rules. Waves propagate through air in pressure patterns that often resemble logarithmic scaling. The human ear, shaped in spirals, approximating the golden ratio, is optimized to receive frequencies arranged in proportional intervals. This may explain why musical scales based on harmonic ratios evoke such powerful emotional responses. The ear is built to resonate with patterns that mirror natural growth, and sound waves that follow these rhythms feel instinctively coherent. Physics and perception merge, revealing that the very geometry of hearing is tuned to the quiet mathematics of proportion. Light, too, interacts with matter in golden patterns. Diffraction, interference, and resonance all produce structures that reflect fractal geometry. When light bends around obstacles or spreads through narrow apertures, the resulting patterns often echo the same proportions seen in spirals and branching systems. These structures arise because electromagnetic waves distribute energy most efficiently when they expand according to proportional scaling. Even photons traveling through space follow paths shaped by gravitational fields that bend in curves resembling logarithmic spirals. The golden ratio once again appears as a bridge between energy and structure. As you let these ideas flow gently through your mind, a deeper understanding begins to settle. Motion itself is shaped by proportion. The natural world flows, spins, echoes, and expands according to patterns that balance efficiency with stability. The golden ratio is not just found in stationary forms, shells, leaves, and buildings. It is present in the movement of water, air, light, and even space-time. It is the geometry of transition, of flow, of energy finding the smoothest possible path. And as this realization softens your awareness, your breath synchronizes with the gentle curves of these natural rhythms, and you drift deeper into the quiet harmony that guides the motion of the universe. When scientists speak about natural intelligence, they often refer to the remarkable ability of ecosystems, organisms, and even molecules to organize themselves without conscious direction. This intelligence is not emotional or logical. It is structural, emergent, arising from the mathematical relationships that allow life to adapt and thrive. The golden ratio lies quietly at the heart of this phenomenon. It appears whenever complex systems find the simplest path to stability, harmony, or growth. It is a geometry that nature seems to know, not through thought but through endless trial, error, and refinement over billions of years. Self-organization begins at microscopic scales. Proteins fold into shapes with astonishing precision, guided by energy landscapes, where the most stable configuration often reflects proportional balance. Microtubules, actin filaments, and cellular scaffolding adopt intricate patterns that follow fractal and Fibonacci arrangements. These structures do not need instructions, they assemble themselves through physical laws that reward efficiency. Natural intelligence emerges from these laws, and the golden ratio becomes one of the quiet reference points that guide molecular behavior. Even though these molecules have no awareness, their shapes reflect ancient geometries that fuel the possibility of life. At larger scales, ecosystems display similar intelligence. Forests distribute tree spacing according to proportional patterns that minimize competition and maximize access to sunlight. Coral reefs expand in fractal arrangements that allow water and nutrients to flow with minimal resistance. Even animal societies, ants, bees, birds, organize their colonies and migrations around spatial patterns that echo Fibonacci scaling. These behaviors arise spontaneously from countless interactions, revealing that the golden ratio is not just a mathematical curiosity, it is an emergent property of systems striving toward optimal arrangement. Human cognition reflects this same principle. Ideas grow in spirals, building on earlier thoughts in recursive loops that resemble natural fractals. Memory expands in logarithmic intervals. Creativity emerges at the edge of chaos, where order and unpredictability merge precisely where golden ratio proportions often appear. This is why certain patterns feel intuitive. The mind evolved within nature's geometry. The golden ratio becomes a symbol of the brain's natural intelligence, aligning internal processing with external structure. Perception, decision-making, and aesthetic preference all unfold along pathways that mirror the geometry of growth. Even technology, when inspired by nature, gravitates toward golden structures. Algorithms for image compression use fractal mathematics that reflect Fibonacci scaling. Efficient network architectures mimic branching systems found in biology. Engineers designing aerodynamic vehicles or energy-efficient buildings often discover that optimal shapes align with golden proportions. These innovations arise not because humans consciously search for the golden ratio, but because the laws of physics and the constraints of efficiency consistently guide designs towards similar solutions. Technology begins to echo natural intelligence, reaching the same conclusions through different means. And as you sit with this realization of a geometry that guides molecules, organisms, ecosystems, minds, and machines, a quiet sense of unity forms within your awareness. The golden ratio is not imposed on the world, it emerges from it. It represents the effortless intelligence of nature, the way complex systems discover balance without thinking, without planning, simply by following the paths of least resistance. It is a soft, universal logic, written into the movements of water, the architecture of trees, the structure of galaxies, and the unfolding thoughts within your mind. And as this understanding settles gently into your breath, you feel yourself aligning with the same ancient harmony, drifting deeper into the quiet intelligence woven through all things. The golden ratio has long been associated with the idea of perfection, a flawless proportion woven into everything from seashells to galaxies. Yet when we look carefully at nature, we discover a quiet truth. The golden ratio appears not as an exact measurement, but as a tendency, a direction toward balance, rather than a rigid rule. Sunflowers do not follow the ratio with mathematical precision. Seashells rarely match it exactly. Even the human body, often celebrated as a golden masterpiece, reflects it only through approximate patterns. And yet these approximations feel perfect because they embody something deeper than numerical accuracy, a natural inclination toward harmony. This reveals an important insight about the universe. Perfection is not a fixed point, but a range, a gentle pull toward equilibrium that allows for variation, growth, and individuality. If every form adhered strictly to 1.618, nature would lose its character, its diversity, its capacity to evolve. Instead, life dances around the ratio, touching it here and there, borrowing from its geometry, but never becoming confined by it. The result is a world that feels balanced without being rigid, harmonious without being uniform. The golden ratio becomes a direction, not a destination, a silent guiding principle rather than a strict command. In this way, the golden ratio mirrors human life. People strive for balance, beauty, and coherence, yet real perfection remains elusive and perhaps undesirable. The mind, like nature, is not designed for precision, but for adaptability. Emotions shift, thoughts evolve, identities transform. The golden ratio appears not in exact measurements within the psyche, but in the overall arc of human growth, moments of expansion followed by reflection, spirals of learning that deepen over time, fractal-like patterns in relationships and memory. Humans grow toward harmony, not into it, and this movement mirrors the gentle asymmetry found throughout nature. Even in art and architecture, the greatest works rarely follow the golden ratio with perfect fidelity. Painters adjust proportions to suit their vision. Architects deviate from strict lines to accommodate function, emotion, or cultural meaning. Musicians stretch timing to create tension or soften a phrase. These deviations do not detract from beauty, they enhance it. They reveal that while harmony provides a foundation, true expression emerges from subtle shifts away from mathematical symmetry. The golden ratio offers a framework upon which creativity can unfold, not a cage, but a canvas. Physics reflects this same principle. Galaxies spiral in golden curves, but gravitational interactions distort them. Hurricanes follow logarithmic patterns, yet wind shear bends their shapes. Rivers carve meandering paths influenced by Fibonacci scaling, but soil composition, terrain, and climate introduce imperfections. These deviations are not flaws, they are evidence that the universe is alive, dynamic, and constantly responding to forces that shift through time. Nature plays near the golden ratio the way a musician plays near a melody, returning to it again and again, but never frozen within it. And as you let this insight settle, a soft calm spreads through your awareness. Perfection, it seems, is not the golden proportion itself, but the movement toward it, the ebb and flow, the spirals, the near misses, the gentle asymmetry that gives life its character. You too are part of this pattern, not perfectly symmetrical, not mathematically precise, but evolving, adapting, and finding balance in your own way. And as this recognition deepens, your breath slows, your mind softens, and you drift peacefully into the understanding that beauty does not lie in exactness, but in the quiet harmony between order and variation, between the ideal and the real, between the golden ratio and the graceful imperfections that surround it. Time, though invisible, unfolds in patterns. Moments stretch, compress, echo, and repeat in ways that mirror the geometry of space. The golden ratio subtly appears in these rhythms, not as a fixed interval, but as a natural pacing, an underlying tempo that guides the way humans experience beginnings, middles, and endings. This structure emerges in the arcs of stories, the progression of emotions, the cycles of nature, and even the phases of a life. Just as spirals grow in harmonious increments, time often feels most balanced when it moves through phases that expand proportionally, creating transitions that feel smooth, inevitable, and deeply human. You can feel this rhythm in the unfolding of a day. There is a moment in late morning when energy rises, the mind clear and expansive. Then a turning point, often near the golden midpoint, when reflection replaces movement and the day settles into a slower pace. Evening brings resolution, a gentle winding down, mirroring the same proportionate flow seen in music, breath, and nature. This pacing is not conscious. It emerges from cycles of cognition, metabolism, and circadian rhythm that align with fractal-like timing. Even the way memories form throughout the day follows a similar pattern, clustering around transitions rather than uniform intervals. Seasons reflect this geometry as well. Spring expands slowly, tentatively, like the opening of a spiral. Summer grows rapidly, fullness, warmth, energy reaching outward in Fibonacci bursts. Autumn represents the turning point, where expansion softens into reflection. Winter contracts inward, completing the cycle before it begins again. These phases are not mathematically exact, yet they evoke the same emotional pacing found in golden arcs. Time, like nature, prefers transitions that flow gently from one scale to another, rather than abrupt shifts. The golden ratio becomes a quiet rhythm guiding the seasons of the earth. Even human life follows these proportional arcs. Childhood unfolds quickly, an explosion of growth and learning. Adolescence marks a golden threshold, a transition from expansion to reflection. Adulthood deepens, widening like the middle turns of a spiral, where experiences accumulate and identity gains stability. Later years soften into wisdom, a convergence of memory and understanding that mirrors the inward curves of natural patterns. No life follows this exactly, yet the underlying rhythm expansion, turning, return, echoes the same geometry found in galaxies, shells, and hurricanes. The golden ratio becomes the emotional pacing of existence. Artistic expression responds to these rhythms instinctively. A symphony that builds too quickly feels rushed. One that lingers too long feels stagnant. When musical passages follow timing ratios near 1.618, the listener experiences a sense of natural progression. The climax feels timed just right, not because of calculation, but because it mirrors the rhythms found throughout life. The same principle applies to literature and cinema. A story that places its emotional peak near the golden division of its length often resonates deeper, aligning with subconscious timing patterns the mind already understands. And as you reflect on the golden ratio's presence in the rhythm of time, a soft realization emerges. Harmony is not only spatial, it is temporal. It shapes not just what you see, but how you move through the world, how you experience change, how you grow, how you rest. Time flows in spirals, arcs, and expansions that mirror the geometry of nature. And as this understanding settles gently within you, your breath slows, your awareness softens, and you drift deeper into the comforting truth that your life unfolds through the same elegant rhythm that guides the unfolding of leaves, the turning of galaxies, and the quiet expansion of spirals in the deep ocean. Human decision-making appears spontaneous on the surface, quick judgments, sudden insights, quiet hesitations, moments of certainty that rise out of nowhere. Yet beneath these experiences lies an intricate geometry of evaluation, weighting, and pattern recognition. The golden ratio subtly influences this architecture, not through conscious calculation, but through the natural organization of cognition. When the mind weighs options, it often gravitates toward balance points that resemble proportional symmetry. Too much information overwhelms, too little produces doubt. The optimal moment of clarity, where understanding feels complete but not crowded, appears near the same threshold where proportion meets intuition. This dynamic is most visible in intuition itself. Intuition is not mysterious. It is the brain processing patterns faster than conscious thought can follow. The neural pathways that support intuitive insight develop through fractal growth, branching, expanding, connecting in recursive loops that mirror natural geometry. When a choice feels right, it is often because the information aligns with proportions the mind recognizes as harmonious. The golden ratio, becomes a cognitive sweet spot, a region where complexity collapses into understanding and where insight emerges with surprising ease. Even hesitation holds this pattern. Before making a decision, the mind naturally enters a reflective pause, a moment of internal stillness where options settle into proportion. If this pause comes too early, clarity is incomplete, too late, and doubt begins to erode confidence. But when the pause aligns with the mind's natural rhythm, its golden interval decision-making feels fluid and grounded. This timing emerges from the same neural oscillations that guide attention, memory, and emotional regulation. The geometry of thought is not linear. It unfolds in arcs that echo the proportions of natural spirals. Behavioral studies reveal that humans instinctively favor choices presented in balanced proportions. Menu layouts, website interfaces, product arrangements, even social interactions when options reflect harmonic spacing. Individuals make decisions more confidently. Chaos in presentation leads to confusion. Overly rigid structure creates resistance. But proportional harmony guides attention gently, allowing the mind to move through options without friction. The golden ratio becomes a silent facilitator of clarity, helping decision pathways unfold with minimal cognitive effort. In creativity and problem solving, the same phenomenon appears. Ideas develop in expanding loops, an initial spark, followed by exploration, followed by refinement, followed by resolution. These phases often manifest in proportional intervals. A breakthrough rarely comes at the beginning or end of the process. It emerges near the golden turning point where exploration has gathered enough information, but the mind remains open to discovery. This balance between the known and the unknown mimics the growth patterns found in nature. Creativity becomes a cognitive spiral, expanding outward through proportional rhythms. And in emotion, proportion shapes how humans choose relationships, environments, and experiences. People gravitate toward moments, spaces, and connections that feel harmonious, neither overwhelming nor empty, neither chaotic nor mechanical. This feeling of rightness often reflects an intuitive recognition of balance, a subconscious measurement against the geometry of natural experience. Decisions anchored in this balance tend to endure because they align with the mind's quiet preference for proportional stability. As you let these insights drift through your awareness, a gentle realization begins to expand. The golden ratio is not just a pattern in nature, it is a pattern in the mind. It shapes how you perceive clarity, choose pathways, trust intuition, and move through life. Decision-making, often seen as a logical process, is also an aesthetic one, guided by harmony, balance, and the quiet geometry inherited from the natural world. And as this understanding settles softly within you, your breath deepens, your thoughts lengthen, and you drift into a peaceful awareness that even your choices unfold through the same gentle proportions that shape spirals, forests, galaxies, and the quiet rhythms of your own inner world. When we step back far enough beyond cells, beyond organisms, beyond planets and stars, we begin to see the universe as a vast, self-organizing system. Structures emerge, disperse, and reorganize with a quiet intelligence that requires no mind, no designer, no conscious intent. The golden ratio becomes one of the signatures of this emergent order, appearing wherever systems evolve towards stability through natural forces. It is not imposed from above. It arises from below, from interactions of matter and energy that gradually resolve themselves into balanced patterns. This proportion becomes a byproduct of the universe learning, through physics alone, how to arrange itself. In the formation of cosmic structures, gravitational interactions sculpt spirals and filaments that reflect logarithmic curves. Stars cluster in ways that balance attraction and repulsion, forming networks that resemble fractals. Dark matter, mysterious, invisible, yet abundant, shapes the scaffolding upon which galaxies form, guiding them into patterns that optimize motion across billions of years. These massive structures do not follow equations explicitly, yet the golden ratio emerges as a natural solution to the problem of distributing matter efficiently across expanding space. It is harmony born from gravity, from time, from the deep equilibrium that the cosmos seeks. Quantum systems reveal similar tendencies on the smallest scales. When particles interact, they often arrange themselves in energy states that reflect proportional spacing. Waves collapse into standing patterns. Fields distribute themselves evenly across space. Probabilities form fractal-like densities. Though these structures are fleeting, arising and dissolving in fractions of a second, they demonstrate the same preference for balance and efficiency that governs galaxies. The golden ratio is not a cosmic coincidence. It is a geometric echo that appears across magnitudes of scale, from quantum fluctuations to the graceful arms of spiral galaxies. This tendency toward self-organization is also evident in chemical evolution. Before life existed, molecules spontaneously formed networks, clusters, and reactions that increased in complexity through proportional feedback. Some patterns stabilized because they were efficient. Others dissolved because they required too much energy. Over time, these reactions produced spiraling chains, self-replicating forms, and early metabolic cycles. The golden ratio's geometry appears subtly in these processes, in the angles of molecular bonds, the spacing of polymer twists, the fractal-like branching of early metabolic pathways. Even before biology, the universe leaned towards structures that mirrored spirals of efficiency. On Earth, this self-organization becomes even more pronounced. The climate system balances heat through atmospheric spirals, oceanic currents, and fractal cloud formations. Ecosystems distribute resources using branching networks that reflect Fibonacci spacing. Human societies form communication patterns, trade routes, and social structures that often mirror natural geometry. These patterns emerge spontaneously, shaped by constraints and opportunities rather than intentional design. The golden ratio becomes a universal answer to the same recurring questions. How do you grow without collapsing? How do you expand without breaking? How do you remain stable while changing? And as you let this understanding unfold within you, a deep sense of connection begins to form. The golden ratio is not merely a mathematical curiosity, it is a reflection of the universe's inherent wisdom, the quiet intelligence of systems finding their way toward order. It appears because nature seeks balance, because energy seeks the path of least resistance, because existence itself gravitates toward harmony. And as your awareness drifts into this recognition, you feel yourself gently aligning with that same cosmic rhythm, the slow spiraling movement that shapes galaxies, life, thought, and the quiet patterns of your own resting breath. And now, as this long exploration draws to a gentle close, you may begin to sense a deeper truth beneath everything we've uncovered. a truth not spoken loudly, not written in equations or carved into stone, but whispered through the structure of the world itself. The golden ratio is more than a number. It is a tendency, a leaning, a soft gravitational pull toward balance that guides seashells, storms, galaxies, and even the drifting pathways of your own thoughts. It is the rhythm behind growth, the architecture behind beauty, the quiet pulse beneath complexity. Everywhere you look, the universe expands in spirals, slow, widening movements that echo the same harmonic curve. Trees branch in patterns that optimize sunlight. Rivers bend in paths that distribute energy. Hurricanes rotate through elegant arcs that mirror the structure of galaxies thousands of light years away. These forms are not identical, not perfect, but they are united by the same instinct for harmony. Nature does not chase precision. It moves toward balance, and in that movement, the golden ratio appears like a distant melody repeating through time. And within you, this pattern lives as well. Your heartbeat follows fractal rhythms. Your breath expands and contracts through proportional waves. Your thoughts spiral gently outward, then inward, exploring new ideas before returning to stillness. Even your emotions rise and fall in arcs that reflect natural geometry. The golden ratio is not something you observe, it is something you are. A quiet echo of the same forces that shaped stars, tides, forests, and every living thing that has ever walked the earth. So as you settle into rest, allow that awareness to soften your mind. Feel the way your breath flows smooth, steady, balanced, as though it were tracing a spiral shape inside your chest. Feel the way your body relaxes in gentle intervals, each release unfolding a little more, a little deeper. You are following the same rhythm that guides the curvature of shells, the branching of trees, the unfolding of galaxies. There is no separation between you and the pattern. You belong to it. You always have. And now, drifting into the last quiet moments of this journey, you can let all remaining tension dissolve outward like the final turn of a spiral, slow, wide, effortless. Let your thoughts settle into the calm center, the still point, the golden balance at the heart of the pattern, a place where nothing is rushed, nothing is forced, and everything unfolds exactly as it should. Tonight, you sleep inside the same harmony that shapes the universe, a quiet geometry, a soft proportion, a golden calm. Good night.